Hello everyone. In this video, we will learn how to calculate the dissolved carbon concentration of steel with changing the CO-CO2 ratio in the gas atmosphere using FactSet software. As we know, in industries, steel is carburized or decarburized using the mixture of CO-CO2 gases. FactSet allows us to directly calculate the change in steel composition with corresponding change in CO2 ratio in the gas atmosphere. In order to calculate, first we have to select a steel composition. In this problem, we will select a steel with manganese and silicon as alloying elements. Manganese to be 0.2 weight percentage, silicon 0.1 weight percentage, and also the carbon is 0.08 weight percentage, and rest is iron. In order to carry out the calculation, first we have to open FactSet, and in FactSet we have to open Equilib module. In Equilib module, first we have to select the databases. To do that, we have to go to data search and push the left mouse button. Then we first select FactPS database because we are using pure CO2 gases, and also we have to select FS steel because we are using steel in our calculation. After that, click OK. After selecting the databases, we have to add the reactant species. To do that, first we have to left mouse button click on this plus sign. First we'll add the steel compositions. To do that, we have to input the chemical formula of the species: iron, carbon, manganese, and silicon. Then we have to add the amount. As we said before, the iron is 99.62 weight percentage, the carbon is 0.08 weight percentage, the manganese 0.2, and silicon is 0.1 weight percentage. After that, we have to add the gas species. The same thing as we have done for steel composition, we have to do for the gases. Here first we input the species name, CO and CO2. Now for gases, the total amount we want to take is 1 mole of gases. So we'll vary the carbon dioxide amount, and then with the varying CO2 amount, the corresponding CO amount will vary accordingly. To do that, first we'll add a variable A, and as the gases are in mole, we'll input mole. Then to correspondingly vary the CO amount, you have to incorporate the total gas amount, which is 1 mole, then minus the CO2 amount, which is A, and then mole. After incorporating all the reactants, we'll go to next. In the next window, we'll select the products. Here, first we'll select the gas. After selecting the gas, we'll have the steel as our product. In the steel, here we are taking single compound. In the steel, here we are using single solution phase. Depending upon the temperature, the steel can be FCC or can be BCC. So we select both of them. Now, as per our problem, our steel is in single phase. So we will change this to single phases. To do that, first we'll go to this area and click right mouse click button and then take single phase. Similar thing we'll do for BCC, and then we want to vary our carbon dioxide amount from 0 to 1, where 0 corresponds to the atmosphere being only carbon monoxide and 1 corresponds to the atmosphere containing pure carbon dioxide, and will vary it with 0.01 mole. The temperature of calculation here we are taking 1200 degrees centigrade, and after inputting all these values we will click on calculate. After Faxage is done with the calculation, it shows the result window for each amount of CO2, and here we get the result gas composition and the steel amount and its composition, where this carbon is a dissolved carbon in steel. So we want to plot the carbon dioxide amount with carbon dissolved carbon in our steel. To do that, we have to go to output and click on plot and then plot results. In plot results dialog box, here we have the axis and the species. The axis, to select the axis, we have to go and click left mouse button. Here in the y-axis, we can take what we want to put in our y-axis. Here we want to put the concentration of carbon which is dissolved in the steel as our y-axis. So we'll choose gram, which will vary from 0 to 0.3 with tick at every 0.01 gram. And in the x-axis, we want to vary the amount of CO2 in our atmosphere, which is from 0 to 1, where 0 corresponds to no carbon dioxide in our atmosphere and 1 corresponds to only carbon dioxide in our atmosphere. Then the species is the species which we want to plot in our y-axis. So we want to plot the dissolved carbon concentration in FCC matrix. So we have to select that. To do that, we have to go to select and click on left mouse button. Here we have to find the carbon in FCC. After clicking on that, we'll click on OK and then plot. Here we can see that Faxage has plotted the dissolved carbon concentration in FCC matrix with variation in CO2 amount. We can change the name of the axis by double left mouse click on this gram, and here we can change the name of the axis. So here our x-axis is mole of carbon dioxide and the y-axis is weight percentage of carbon in FCC matrix. So this is how we can plot the concentration of steel with variation of CO2 in our gas atmosphere. Next, we want to calculate the optimum amount of CO2 which is needed to reduce the dissolved carbon in steel to a targeted composition. This means that we want to exactly calculate what is the amount of CO2 which is required in the gas mixture to get a targeted composition of carbon in our steel matrix. In order to do that, we have to go to the menu window in our equilibrium module and right mouse click on this area and select composition target. Here this composition target dialog box opens. Here we want to target our element composition. So we click on that and from here we can choose which element we want to target. So in this case we want to target the exact composition of carbon. So here we'll select carbon. So what is the target? We want to change the carbon composition from 0.005 mass fraction, which is 0.05 weight percentage, to 0.002 with a variation of 0.0001. So this is our target. So the carbon composition in steel at 0.005 to 0.002, we want to check that what will be the CO2 amount required in the gas. So after that, click OK and then click Calculate. After clicking Calculate, FactSearch gives us the results. Now we want to plot to see that how the target for the target carbon compositions, what is the variation of CO amount in our gas is needed. So in order to do that, we have to go to the output, use left mouse button, click on it and then plot results. After the plot data dialog box opens, we have to go through the same procedure as before. We have to click on axis where we select the y-axis parameters and then we also incorporate the x-axis values and then click on OK. In the species, we again select the carbon in FCC, dissolved carbon in FCC phase, click on OK and click on plot data. In plot data, we'll get this diagram where it shows that for the specific carbon concentration which we have targeted, what will be the CO2 amount as alpha. So again we can change the axis by left mouse button double click on this text and change alpha to mole CO2 and y-axis as weight percentage of carbon. So this is how we can calculate for a target carbon composition in our matrix what should be the mole of CO2 required to take in our gaseous atmosphere.